Okay, so the focus is on us verifying these trigonometric identities. So when you look at these problems, you should notice a little bit of a difference in the way the problems are set up. You're given information on each side of an equal sign. So it's more or less an equation. And what we're trying to do is we're trying to verify the equation. So you're still going to be utilizing some of the same steps that you have previously in worksheets 1, 2, and 3. But the only difference now is we're trying to make the left side of the equation and the right side of the equation the same. And that's what we mean by verifying the trigonometric identity. So for some of you, as you work through these, some of you will finish at different places when you're verifying. The thing that as you do these is you will know that you have it verified once the left side is the same as the right side. So the steps you make, you may only make steps on the left side to make this the same as the right side. You may have to make steps on the left side and the right side. You may only make steps on the right side. So depending on the process that you utilize and what you decide to simplify to make them the same, it may be different for each of you. But once you've showed that the identities are the same, then you're complete with the problem. So I'm going to take number 5. That'll be our first example here from the worksheet 4. So here's what it says. It says we've got sine squared theta over cosine squared theta equals secant squared theta minus 1. So again, you got to make some decisions here on which side you would like to simplify. You can kind of see here on the left we've got sines and cosines. On the right we have secant. But there should be some things here that kind of stand out to you as you're going down through your green sheet. We don't have any multiplication identities, but we do have a Pythagorean identity. We have secant squared minus 1, which we know secant squared minus 1 is the same thing as tangent squared. So I'm just going to, for purposes of this one, I'm going to change the right side to tangent squared theta. If I look at the left side, I know that sine over cosine is also tangent, and they're both squared, so really that just becomes tangent squared theta. So in simplifying that, this one's just a one-step simplification or verification. We have the same thing on both sides of the equation. So we're done with that. Let's try number 6. Number 6, we've got sine squared x minus 1 equals negative cosine squared x. And I think you're going to find that these are a little bit shorter in some cases, just depending on the way that they're written. And you may start simplifying one side and figure out, well, that's maybe not going to work. So you may have to, go back through some of your steps as you work through this. So first one, as we're going through here, sine squared x minus 1. Well, we know that that's one of our Pythagorean identities. We know that sine squared x minus 1 would be, and again, you have to manipulate on your green card. We know that would be the same thing as negative cosine squared x. Well, it just so happens that's what we already have on the other side. So again, that was just a one-step simplification. Okay, let's go ahead and move on to number 7. I'm going to do a few more of these just so you can kind of see the process. So 1 plus sine x over cosine x equals cosine x over 1 minus sine x. Again, as you look at this, this setup on this one is more like a proportion. If you think back to geometry class, with a proportion, one of the ways we can solve a proportion is just simply by cross multiplying. So if I cross multiply, it kind of gets rid of my fractions. I get cosine squared x. And if I do the cross multiplication here, I get 1 plus sine x times 1 minus sine x. And again, from our algebra steps, 1 plus sine x times 1 minus sine x is 1 minus sine squared x. And again, we know that 1 minus sine squared x is one of our Pythagorean identities. We know that that's equal to cosine squared, so we can say cosine squared x equals cosine squared x. Let's go ahead and do number 8 together. Number 8, we've got cotangent plus sine, actually no plus, just sine equals cosine. Okay, so what I would do probably for this one, probably best idea would be to change your cotangent to a cosine over sine. Not really much we can do with the right side. And then you notice the sines will cancel here, so we're left with the cosine equal to cosine. So again, there we have verified that the left side and the right side are exactly the same. So as you're working through these, again, you're looking at just trying to make the left side the same as the right side. Treating it pretty similar to an equation using your identities that we've been doing. And like I said, some of you may end at different places. I mean, it would be okay if you had a 1 plus sine x on one side and a 1 plus sine x on the right side. It doesn't have to be just a single trig identity for it to be verified. So just as long as you have showed that the left and the right sides are the same, that's good enough for your verification. So as you work through these, again, these are not quite as long. We're going to finish up this packet for next week, worksheet 4 and worksheet 5. As you can see, I've already done 4 of these for you in terms of practice and kind of demonstrating that. Next week, we're going to do question answer time on Monday and Tuesday. And then we're looking at testing over this material next Wednesday, Thursday in class. So that's kind of where we're going with the calendar and with as we look ahead. What I'll do at this point is I'm going to stay on here as long as you need me to stay on to answer questions about any of the other worksheets. So if you feel like you're good in understanding the verification and you don't have questions over worksheets 1, 2, or 3, feel free to leave the Zoom at this time, and have a great weekend. If you do still have questions, I'll stay on here as long as you need me to stay on to answer your questions.